Nikola Tesla was a Serbian-American inventor, electrical engineer, mechanical engineer, and futurist who made dozens of breakthroughs in the production, transmission and application of electric power. He invented the first alternating current, AC, motor and developed AC generation and transmission technology. He was born in 1856 in Smiljan, which was then part of the Austrian Empire and now in Croatia. He had 4 siblings, one of whom died in a riding accident. His father was an Orthodox priest and his mother had a talent for making home craft tools and memorizing Serbian epic poems. He never married or had children because he believed his masculinity helped him develop his scientific knowledge. He died in 1943 in New York and his remains are preserved at the Nikola Tesla Museum in Belgrade, Serbia. He studied engineering and physics in Austria and Prague, but did not receive a degree. He worked in Paris for the Continental Edison Company, where he improved the design of dynamos. He immigrated to the United States in 1884 and briefly worked for Thomas Edison, but soon left due to their differences. He sold his patent rights to his system of AC dynamos, transformers, and motors to George Westinghouse, who used them to power the world's first long-distance transmission line at Niagara Falls *1 *2. He also experimented with wireless power transmission, radio waves, X-rays, high-frequency currents, and various devices such as the Tesla coil, the induction motor, the plasma lamp, the radio-controlled boat, and the death ray. He had a visionary imagination and a poetic touch, but also suffered from eccentricities and paranoia. He often clashed with his rivals and critics, such as Edison, Marconi, and J.P. Morgan. He died alone and impoverished in a hotel room, leaving behind hundreds of patents and inventions. Nikola Tesla's valve is a device that allows fluid to move in one direction without any moving parts or external force. It is also called a valvular conduit or a Tesla valve *1 *2. The device was designed and patented by Nikola Tesla, a Serbian-American inventor and engineer. In 1920, he intended to use it for his new steam engine, but his project was abandoned due to financial difficulties. His patent was largely ignored for decades until it was rediscovered in recent years by researchers and engineers. The device consists of a series of interconnected, asymmetric, tear-shaped loops that create a one-way flow through the conduit. The loops are oriented in such a way that fluid can easily travel through the device in the forward direction, but is slowed and blocked by vortices and turbulent flows in the reverse direction. The device achieves this with no moving parts, other than surface friction. The device works better with pulsatile flows, such as those produced by pumps or engines, than with steady flows. The device can also smooth out pulsing flows, similar to how AC-DC converters turn alternating currents into direct current *2. The device has potential applications in microfluidics, aerospace engineering, biomedicine and industrial fluid pump technology. It can provide a durable, efficient and adaptable way to achieve a one-way flow without moving parts or external force *1. Shark intestines function like Nikola Tesla's valve is a discovery that revealed how shark intestines work like a device designed by Nikola Tesla in 1920. Tesla valves are devices that allow fluid to move in one direction without any moving parts or external force. Shark intestines have similar shapes and functions, which help them digest food efficiently and prevent backflow of waste *2. The discovery was made by researchers from California State University, Dominguez Hills, the University of Washington and University of California, Irvine, who published their findings in July 2021 in the journal Proceedings of the Royal Society B *2. The researchers used a computerized tomography (CT) scanner to create 3D images of shark intestines, which came from specimens preserved at the Natural History Museum of Los Angeles. The CT scanner works like a standard CT scanner used in hospitals. A series of X-ray images is taken from different angles, then combined using computer processing to create three-dimensional images. This allows researchers to see the complexities of a shark intestine without having to dissect or disturb its superscript 2. The researchers found that shark intestines have different shapes depending on the species, but they all have some form of spiral, scroll or funnel structure that creates a one-way flow through the digestive tract. The spiral shape slows down food movement and sends it down through the gut, mainly depending on gravity and peristalsis, the rhythmic contraction of the gut's smooth muscle. The twisted architecture also promotes a one-way flow by creating vortices and turbulent flows that block any reverse movement of food or fluid superscript 2 superscript 3. The researchers compared the shark intestines to Tesla valves, which are devices that have a series of interconnected, asymmetric, tear-shaped loops that allow fluid to easily travel through the device, but slow and block any returning liquids. Tesla designed these valves as part of a new steam engine he was working on, but filed for bankruptcy several months later, leaving the patent forgotten for decades. Tesla valves have been rediscovered in recent years and have potential applications in microfluidics, aerospace engineering, and biomedicine superscript 2 superscript 3. The researchers speculated that shark intestines function like Tesla valves because they provide an energy-saving form of digestion. Sharks have a slow metabolism and need to extract as much nutrients as possible from their food, which can be scarce in the ocean. By having a one-way flow through their intestines, sharks can reduce the energy they expend pushing food in the right direction with muscular contractions. They can also prevent any backflow of waste that could contaminate their food or cause infections superscript 2 superscript 3. The researchers also suggested that studying shark intestines could inspire new designs for industrial fluid pump technology that can achieve a one-way flow without moving parts or external force. Such technology could be more durable, efficient, and adaptable than current systems superscript 2 superscript 3. If you like the video, please hit the notification button and subscribe and like our channel.